All right, so we've talked about what it means for two shapes to be congruent, especially triangles, and the little tricks that we can do to show triangles are congruent. We had angle, side, angle, side, angle, side, and stuff like that. That's to show that triangles are congruent. Now we're talking about what it means to be similar. And they give us a picture here, and they give us two triangles, and they tell us that they're similar. Now I did actually measure the angles, and so these are accurate angle measures. I just made up these side lanes for simplicity's sake. Okay. So if I measure all the angles of triangle ABC, I get that the measure of angle A is 46 degrees, the measure of angle B is 105 degrees, and the measure of angle C is 29 degrees. Then I go to the bigger triangle and I measure the corresponding angles, and I get that angle X is 46 degrees, angle Y is 105 degrees, and angle Z is 29 degrees. Okay, so that should show us something. If triangles are similar, if shapes are similar, the corresponding angles have to be congruent. So the angles will match up perfectly. Okay, then I go measure the sides. And again, I didn't actually measure these sides. I just made them up just to make the math easy. So if I measure the side of AB of this triangle, I'm putting that's 2. And if I measure the side AC, I'm going to put that's 4. And I'm going to put side BC is 3. So now if that's true, and these shapes are similar, then one number that these sides could be is XY could be 4, XZ could be 8, and YZ could be 6. So again, they don't have to be congruent like the angles were. The angles do have to be congruent if they're similar. What needs to be true is that there needs to be a common scale factor. There needs to be a common number that is going to be multiplied between the two sides. So example, they took 2 and multiplied it by 2 to get 4. They took this side length that was 4, multiplied it by 2 to get 8, and they took this side length that was 3, multiplied it by 2 to get 6. So again, it's like what we're doing in class. There's some number that they multiplied all the sides of one shape by to get the either smaller shape or bigger shape. Okay, so now, what does it mean to be similar? Similar means that two figures that have the same shape, they have to have the same shape, but not necessarily the same size. They might have the same size, but they don't have to. That's not part of the definition. All the definition says is that they have the same shape, and again, they may or may not have the same size. What are similar polygons? Two polygons whose corresponding angles are congruent. Again, the corresponding angles have to be congruent, and the corresponding sides not congruent but proportional. Again, that's what we spent last class doing, talking about what it means to be proportional. In a similarity ratio, it's the ratio of two corresponding linear measurements in a pair of similar figures. Basically, what did they multiply the first shape by to get the second shape? Okay, so now what does that mean and what does it look like? First of all, I do apologize for these pictures. When I make copies, the symbols in the pictures don't always show up. So in this one, there were two arcs on angle J, and there were two arcs in angle N. I don't think they showed up on your paper. There was also one arc on angle M, and there was also one arc on angle S. So now if two angles of this triangle match two angles of this triangle, what we should know by now is that the third angles must also match. So I went ahead and put 3 arcs there and 3 arcs there. So now I know that all my angles are congruent to each other. Okay, so that's one part of my definition. So for these two shapes to be similar, all the angles have to be congruent, which I just showed that they are. Now I have to show that the sides, again, not congruent to each other, but proportional. So what does that look like? Okay, so I'm going to take MJ. MJ goes from one arc to 2 arcs. So which side in this triangle also goes from one arc to 2 arcs? So MJ goes from one arc to 2, MJ, and that's 45. And now that has to be proportional to the corresponding side that also goes from one arc to 2 arcs, which is SN. So I'm going to take MJ and put it over SN, and I see that that's just 45 over 22.5, which just equals to 2. So now all the other sides should have that same ratio if they're similar. So let's keep going. So now I'm going to take LJ. LJ goes from 3 arcs to 2. So LJ, 3 arcs to 2. Which one of these goes from 3 arcs to 2? PN goes from 3 arcs to 2. So I've matched up the pieces and I put LJ over PN, which is 70 over 35, which again does equal to 2. So it's looking like it's going to work. Let's check the third side. So LM. LM goes from 3 arcs to 1. And over here, that is PS, 3 arcs to 1. So I put LM over PS, which equals 60 over 30, which does equal to 2. So 2, 2, 2, and all the angles were congruent, which means I have similar triangles. And if you're asked to write a ratio, my ratio of triangle LMJ to PSN is 2 to 1. This one is twice as big as this one. And just like when I'm doing congruence, the order does matter. This little squiggly line means similar. So I'm going to say triangle LMJ is similar to triangle PSN. And again, the order does matter. Once you pick the order of the first triangle, you have to go in the same order in the second triangle. Okay, let's try another example. And again, I do apologize for this bad picture on your notes. I think this one had 1 arc. This one also has 1 arc. This one has 2, and this one has 2. So that's what we're told. And again, we're expected to remember that if 2 angles of one triangle match 2 angles of another, that the third angles must also match. So then UT must also be congruent to each other. And then I just do what I did a while ago. Okay, so I look at TR. TR goes from 3 arcs to 2. So that would mean going from UW over here. And of course I wrote it wrong. I went in the wrong order, whatever. I'll fix that. So I have TR over UW, which is just 16 over 12, which is 4 over 3. So now let's make sure all the other sides have that same number. So then I go SR, and SR goes from 1 arc to 2, which means VW, and again I put WV. 20 over 15, which is 4 over 3. Matches up. And the last one, TS over UV, is 24 over 18, which is 4 over 3. So again, they're all equal to 4 over 3. They are all proportional. So if I'm going to write it, the ratio of triangle TSR to triangle UVW is 4 to 3. And if I write the statement, triangle TSR, this little squiggly means similar to UVW. Okay. So now, what does that look like in this shape? So again, in this shape, another bad problem with the angles. This one you should see 2 arcs. This one you should see 1 arc. This one you should see 2 arcs, and this one you should see 1 arc. So now I'm going to write my statement first. It already told me that they're similar, so I'm not trying to figure that out. We already know that's true. So I'm just going to go in order. I'm going to go from E, from the 1 arc to the 2, and then I'm going to keep going this direction. So I'm going to go E, A, B, C, D, which I wrote here. E, A, B, C, D is similar to, and then I'll go in the same order over here, 1 arc to 2 arcs, and then keep going that direction. So I, J, K, G, H. So they turn the pictures around. Again, they're trying to confuse. That's why we got to use these angles to make sure that we're staying on track. Okay, so now this picture tells me everything that I need to go. I know angle E is congruent to angle I, A is the same as J, B is the same as K, C is the same as G, and D is the same as H. And I know side EA proportional to IJ, AB to JK, and so on. Okay, so now I look at the picture, and I look at X. Well, X is with G. Well, then I can look over here. Well, G is in the same spot as C, so G and C must be the same. So if C is 100, that means X has to be 100. Okay, and then I look at the W. Where's the W? W is the same as K. Well, K is in the middle, and so is B. And so K and B have to be the same. Well, if B is 123, then K's got to be 123, and so that means W must be 123. Okay, so those are the easy ones. Now, how do we get the side lengths? Okay. Let's see how we can do this. Okay, so we're going to try to get the Y. Actually, you know what? Let's get Z first. Let's try to get the Z. And the Z is right here. So the Z is side length AB. Can't get it to show up. Z is side length AB right here. Now if I go back to my statement, AB of the bigger one, which is right here, AB, matches up to which piece in this side? JK. So AB should be proportional to JK. And so that's what I put. I put AB proportional to JK. AB over JK. Now let's match up something else in the pictures. Well, BC, which is right here, is matching up with KG. So BC should match up to KG. Well, I already know here that BC is 6 and KG is 4. Okay, so BC over KG has to equal AB over JK. And then I just plug in. The picture tells me that BC is 6. The picture tells me KG is 4. AB is Z. And JK is 6. Cross multiply, and I get 36 equals 4Z. And then I get Z is equal to 9. So again, the hard part is just trying to figure out, which piece goes to which piece, but that's why setting up this kind of statement will help you. Okay, so now let's do it again to try to find the y. Okay, so here's the y. And do me a favor, this was another mistake. I think you should say 2y plus 1. Just cross off the plus 1 and just make this 2y. So ij is equal to 2y. And I know from here that ij is proportional to ea, so that's what I did. I put ea over ij. And then I said, well, that's got to be equal to BC over KG. So then I just plugged in. Well, EA is 9, IJ is 2Y, BC is 6, and KG is 4. Cross multiply, and I get 12Y equals 36, so Y is equal to 3. Again, the angles are congruent to each other. What you're going to be tempted to do is say that the sides are congruent to each other too, just set them equal to each other and solve, but that's not true. The sides are not equal to each other, they're proportional to each other. We'll do a lot of practice in class, just try to have the basic understanding of how this is working. Again, I don't expect you guys to come in experts. Just come in with the basic understanding of what we're going to try to do in class. We're going to ignore this piece at the bottom. Alright, some definitions. And again, most of it's already filled in. We're just going to fill in some blanks. Okay, angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So it's enough for me to know if I have two triangles and two angles of one triangle are congruent to two angles of another triangle, the triangles are similar. All right, so again, these are little shortcuts that we can use. Side-side similarity. It says that three sides of one triangle are proportional, again, not congruent, proportional to the three sides of another triangle, then the triangles are similar. So this tells me I don't need to know anything about the angles. If I know all the sides are proportional, then I know the triangles are similar. And the last one, side angle side similarity. If two sides of one triangle are proportional to two sides of another triangle and their included angles are congruent, the angles in between the two sides, then the two triangles are similar. Okay, so let's do one. So this one's just telling me, can I show that these two triangles are congruent? I'm trying to, similar. This triangle and this triangle. It's asking me to show, are they similar to each other? Well, okay, let's mark up what I know. Well, I know these two are vertical angles, so they have to be congruent. Okay, these are parallel lines, so I have alternate interior angles, so this angle has to be congruent to this angle, and this angle has to be congruent to this angle. Well, I know all my angles are congruent. And we just learned up above that if two angles of one triangle are congruent to two angles of another triangle, then my triangles are similar. Well, if all the angles are similar, then my triangles have to be similar. So I'll make my statement, triangle CAB. So I went CAB, 1 arc to 2 arc to 3 arcs. Similar, little squiggly line, to triangle CED. And what method did I use? I used AA. Okay, see what you can do with these next two. I'm not going to do these. Just I marked that for you already. Just see what you can do. And we'll talk about the rest in class. Again, just have an idea of what we're trying to do. I don't expect you guys to come in knowing how to do it all.